Hi friends, welcome back to our channel Easy Mathematics. Today we are going to discuss a very important 6-mark question from three-dimensional geometry. So this question is about plane. In plane we have discussed equations of plane, angle between two planes, distance from a point to a plane, and angle between line and a plane. So these are the four major important topics that we covered under planes in three-dimensional geometry. So a 6-mark short question we can expect from this section plane. So one question, 6-mark question we can expect from the section is this one. So we have different types of 6-mark question in this section, but one among them is this one. So here what we want to find the equation of the plane that contains the point 1, -1, 2, and that plane is perpendicular to each of these planes. 2x plus 3y minus 2 is equal to 5, and x plus 2y minus 3z is equal to 8. So we want to find equation of a plane passing through one point and that plane is perpendicular to two different planes. To find equation of plane, here we want to make use of one point formula, isn't it? The plane is passing through one point, that point is given 1, -1, 2, and that plane is perpendicular to two different planes. So we want to make use of that equation. When two planes are perpendicular, what is condition of their normals? So these are the two ideas that we want to make use in this question. So first, given point 1, -1, 2, you choose it as x1, y1, z1. Then apply in one point formula. So what is one point formula? The required equation of plane is a into x minus x1. So I am choosing x1 as 1 given point, plus b into y minus y1. So y1 is -1. So y minus -1 becomes +1, plus c into z minus z1, that is 2, is equal to 0. So I am choosing this equation as equation number 1. So this is our required equation of plane. Then here, if we are able to find value of ABC, we are done. So we want to find value of ABC. To find value of ABC, we want to make use of our second condition. This plane, equation 1, is perpendicular to those two planes. When two vectors are perpendicular, then direction ratio will satisfy the condition a1, a2 plus b1, b2 plus c1, c2 is equal to 0. Isn't it? Direction ratios of that vector satisfies this condition. So that condition we want to apply here, because two planes are perpendicular, then their normals are also perpendicular, isn't it? So direction ratios of normal will satisfy that equation a1, a2 plus b1, b2 plus c1, c2 is equal to 0. So that condition we are going to use here to make two equations involving A, B, C. To form first equation, required equation of plane, that is equation 1 is perpendicular to first plane. We want to make use of that condition. Equation 1 is perpendicular to the first plane, 2x plus 3y minus 2z is equal to 5. Then direction ratios of the normal will satisfy the condition a1, a2 plus b1, b2 plus c1, c2 is equal to 0. So here what is a1, b1, c1? a1, b1, c1 I am choosing it as the direction ratios of given plane. So a1 is 2, b1 is 3, c1 is -2. a2, b2, c2 I am choosing it as a, b, c. Then how we can apply that condition? a1, a2 plus b1, b2 plus c1, c2 is equal to 0. Applying the condition, we get a1 is 2, a2 is a. So 2a plus 3 into b minus -2 into c, that is -2c equal to 0. Second equation. Then to get the second equation involving ABC, we are using first equation 1 and second equation of plane. So here I am choosing A1, B1, C1 as 1, 2, minus 3 direction ratios of normal. Then here A2, B2, C2 I am choosing it as ABC. Then applying A1, A2 plus B1, B2 plus C1, C2 is equal to 0 condition, we get second equation, that is 1 into A, then 2 into B plus 2B minus 3 into C, that is minus 3C equal to 0. I am choosing it as equation number 3. So solving 2 and 3, we can find the value of ABC. To find the value of ABC, here we have two equations involving three unknowns. So we are using cross multiplication method to find values of ABC. So how we can apply that cross multiplication? Very important one point. So I am writing it as A, B, C, A, B. So here I am repeating AB. Then coefficient of A, B, C I am writing it. So from equation 2, what is coefficient of A? 2. So below this A I am writing 2. Same manner, coefficient of B, coefficient of C, and I am repeating AB again. 2, 3. Then from second equation, third equation, I am writing coefficient of ABC. So 1, 2, minus 3, 1, 2. How we can apply cross multiplication here? So I am writing A divided by, then I am deleting a row and column involving A, then deleting this row and column, then we get, I am cross multiplying this two. Then what we get? 3 into minus 3, that is minus 9, minus 2 into minus 2, that is minus 4. So minus of minus become plus 4. That is equal to B divided by, then I am deleting a row and column involving B and cross multiplying, we get minus 2 into 1, that is minus 2 minus. So minus is the common sign between these two, cross multiplication. Okay. Then minus 3 into 2, that is minus 6, minus into minus become plus 6, equal to C divided by, plus multiplying this 2. That means we want to delete a row and column involving C. Then we get 2 into 2, 4, minus 1 into 3, 3. I am choosing it as K. So this is the procedure for finding value of ABC. So normally we cannot find the value of ABC because only two equations are given involving three unknowns. So this is the procedure that we want to follow in this case. Then what is value of ABC? From here we can find value of ABC. A is equal to A divided by minus 5 is equal to K. I am equating first term and last term constant K. Then A by minus 5 is equal to K. That implies A equal to minus 5K. Then same manner, B divided by minus 2 plus 6, that is 4. B divided by 4 is equal to K, implies B is equal to 4K. Then same manner, C divided by 1 is equal to K, that implies C equal to K. Substituting these values in the equation number 1, we get equation of plane. Using cross multiplication method, we already found the value of A, B, C. A equal to minus 5K, B is equal to 4K, C equal to K. Then this values we are substituting in our equation number 1. So this was our equation number 1. A into x minus 1 plus B into y plus 1 plus C into z minus 2 is equal to 0. Then I am substituting value of ABC here. Directly I am substituting value of ABC. So A I am replacing with the minus 5K, x minus 1 plus B 4K into y plus 1 plus K into z minus 2 is equal to 0. So I am substituting value of A, B, C in equation number 1. Then from all the terms, what we can take commonly outside? K we can take commonly outside, and that K, if we are taking to this side, what we get? 0 by K become 0. So what will remain here? Minus 5 into x minus 1 plus 4 into y plus 1 plus z minus 2 is equal to 0. So I am taking K commonly outside and I am taking that K to right hand side, then it becomes 0. When I am cross multiplying, not cross multiplying, I am opening this bracket and simplifying, we get equation of plane. Open the bracket, then simplifying, we get equation of plane. Then minus 5 I am taking inside, then we get minus 5x plus 5 plus 4y plus 4 plus z minus 2 equal to 0. Then I am taking all xy term, xyz term together, then minus 5x plus 4y plus z, then remaining here plus 5 plus 4, 9, 9 minus 2, 7, plus 7 I am taking to that side, and it becomes minus 7. So this is the required equation of plane. This is a very important 6 mark type question. So here we applied 1 point formula and cross multiplication method. So very important one point that we want to remember here is that cross multiplication method. Equation of plane passing through one point and perpendicular to two different plane. In all type of this question, we are using same procedure, 1 point formula and cross multiplication method. I hope this video is clear to all, and try to solve 1 or 2 similar type questions to make the concept thorough. So thank you for watching.